No, see, this is not a deterministic problem. Okay, linear optimization is not deterministic because we don't know exactly how many computers or how many products we can sell, right? If you knew exactly, okay, that we can sell 100 notebooks and we can sell 100 notebooks and we can sell 250 desktops. If I'm giving you this value, then it's easy, right? Notebook, we have 750 rupees profit, and for desktop, we have 1000 rupees profit. Then I can easily find, okay? You can easily say 750 into 100 plus 1000 into 250. Okay, this is the profit that we are going to make. But we don't know this. This is not known. Correct? This is not known. So if we can, so our main objective is to find these values. If you're able to find these values, then we can easily find the profit, isn't it? So let's assume that we are manufacturing only one notebook and only one desktop. Let's assume. Okay, and we will try to solve this. Okay, so the actual our objective function is, let's say, this is x value. So ultimately we will end up getting x value and this is y value. So our objective function is to maximize profit, right? So profit we need to maximize. Maximize what? 750x plus 1000y. What is the maximum value of this? This is what we need to find. Did you understand, everyone? Our objective is, sir, yes. So see, what it says is, it says that an Indigo company makes notebooks and desktops. Okay, and notebook is given 750 rupees profit and desktop is giving 1000 rupees profit per piece. So how many notebooks and desktops should we make so that we get maximum profit, right? So let's assume that we have X number of notebooks that we need to make and we need to make Y number of desktops. Okay, let's assume X number of notebooks and Y number of desktops. So your profit will be what? 750X plus 1000Y. Yes? 750x plus 1000y is your profit. Okay, so this is called objective function. This is what we need to find out. We need to find the value of x and y. Yes or no?
Yes, sir.
Okay, now it is clear. Did you understand?
Yes, sir.
Okay, so this is called objective function. This comes from what you need to find. Okay. To solve the problem, let's assume that we will make only one notebook and we'll make only one desktop. So then profit is this. This is profit, but this may not be the answer because this may not be the maximum profit. We're talking about the maximum profit. This may not be the maximum profit. This is one of the answer, but this is definitely not the final answer. Okay. This is profit you'll make if you sell one notebook, but is that the maximum? No. So then what is maximum? So we have to look at the constraints. Okay, we have to look at the constraints. So what are constraints here? Okay, so the first, so I think there are three constraints here. So first constraint you see, what it says, each computer, okay, requires a processing chip, okay, and due to the problem in the market, only 10,000 chips are available. Each computer requires one chip, right? That's what it is. Each computer requires a chip. So if you have X number of computer, you need X number of chip. If you have Y number of computers, you need Y chip, right? So we are assuming that, okay, we are assuming that we have only one computer. So you are using one chip here and one chip here. Okay, and what we are saying is x into 1 plus y into 1, x plus y. Okay, this is 10,000. This is the maximum. So you can see this 10,000 chips you have got, but doesn't mean that you will be using all the 10,000. You cannot make 1001 computer, but you can definitely make, sorry, 10,000. You can't make 10,001 because maximum chip that you have is 10,000. So this example is, we call it as less than equal to. Less than equal to because your total number of chips you can use less than 10,000. Okay, but you can't use more than 10,000. So this is your first constraint. Second constraint, if you see, it says here, each computer requires memory, fine. Memory comes in 16 chip. Okay, so we have 16 chip memories only. A notebook needs 16 memory and desktop needs 32 memory. That means you have 16 MB chipset, notebook needs 16. So one chipset is for notebook is enough, but you need to have two chips, 32 chipset. So you need to have two chips for desktop. Okay, and how many chipset you have total? It says total we have 15 chipsets. So you put 15 here. Any question here, guys? Did you understand this constraint? It says
Yes, sir.
every computer needs memory chipset, notebook needs 16 GB, 16 MB, and desktop needs 32 MB. So 32 MB you need two chipset, right? 16 plus 16. So, okay, x into 1 and y into 2 should be less than equal to 15,000. So third constraint, each computer requires assembly time. Okay, the labors will work to assemble. So due to the time tolerance, a notebook takes more time to assemble. So you have 4 minutes time for notebook and 3 minutes for desktop. Okay, and there are 25,000. Okay, so 20,000 minutes only labor will work, 8 hours per shift. So what we are saying is 4 into x plus 3 into y is less than 25,000. So in terms of algebra, our equation will be x plus y is less than equal to 10,000. X plus 2y is less than equal to 15,000, and 4x plus 3y is less than equal to 25,000. Okay, so this is the equation and this is how we write in Excel. Okay, we go to add-ins. Okay, add-ins. Okay, then here you go and select Excel add-ins. Okay, go. The solver add-in, yeah, this is not add-in, right? Solver add-in. Solver add-in will solve linear optimization problems. You say okay. When you say okay, okay, so I think solver has come here, right? Solver has come here. Now I was saying that we need to develop this. Okay, so see here. Let me move this to this part here. So this is our right hand side. When I write the equation, right, this is our right hand side, RHS. What is left hand side? Left hand side is x plus y. So right now we have assumed, what is the x value right now? We have assumed 1, isn't it? So we are saying 1 into 1, right? So 1 into x plus 1 into y. Okay, so 2 less than equal to 10,000. Perfect. Now here I am saying x plus 2y, right? So x is 1x, 1 into 1 plus 2 into 1. So x plus 2y, 1 into x plus 2 plus y, right? 3 is less than 15,000, which is good. And now finally it says 4x plus 3y, right? So 4x is 1 for now, right? And then you have 3 into 1. So 237. Okay. So if you make one computer notebook and one desktop, this is what you will get. Correct? 2357. But maximum, how much can we make? Okay. So for that, we use solver here. Go to data, get the solver. Okay. Now we'll solve it. See, target cell. What is target cell? What is that you're trying to maximize? We're trying to maximize this. This is your target cell, right? This is the profit. We have assumed one desktop, one notebook. This is the profit, but our target cell is to find maximum value for this, right? So this is the so target cell, and what do you want to do? You want to find maximum, minimum, or perfect. I say I want exactly 10,000 profit. Then you'll put 10,000 here. So equal, right? But I want maximum. So maximum of this cell, fine. By changing cell, which cells are you changing? We are changing these two cells, isn't it? So we are changing this and this. These two cells we want to change. So we want to check with 1, then with 2, then 3, then 4. Okay, we are changing different numbers and see what is the maximum computers we can make. Okay, given the given constraints. So add here where we have to add all the constraints. So what is the first constraint? First constraint says left hand side. So 2 is less than, constraint is 10,000. Okay, if it is 1 1 now, so this should be less than. So when you're increasing 1 to 2 to 500 to 1000 so on, this value cannot go more than 10,000. That's what it says. So this becomes constraint. D10 is less than equal to F10. Okay, we have to add one more, the third one. D11 has to be less than F11. Okay, then we have to add one more, which is D12 should be less than equal to F12. You say, okay. All the three constants got added. Okay, all three constants got added. This is our the values that we need to change, and this is what we want the maximum. There are three things you have to enter. Which number you want to put maximize or minimize. Sometimes problem will be minimize also. Then you say minimize. Here it is maximize. So D3 is maximize. Okay, changing cell. These two is what we are trying to change. To begin with, we said 1 1, but actually it can be 500,000 whatever, right? So we are saying changing cell, and given these constraints, okay, given LHS is less than equal to RHS. Now you say solve. Okay, that's it. When you say solve, it has solved the solution. Okay, so see what it says. We should make 1,000 notebooks and 7,000 desktops. So 1,000 notebooks, 7,000 desktops, you get 8,000 less than 10,000, 15,000 is less than equal to 15,000, 25,000 is less than equal to 25,000. All these conditions are met. So what is the maximum profit you can get? This is the maximum profit you can get. One single click and you got the answer. Did you understand? It is all about solving using solver, linear problem. So which cell you want to change? We want to change these two cells, right? Maximize by change. Okay, sorry, my mistake. Which cell is the answer? This cell, okay, not that. We want to maximize this one, D3. We want to maximize D3. Okay, so here you will have D3. D3 is what we want to maximize. Okay, and then maximize to what? Maximum of D3. Okay, by changing what? Which cells you need to change? We need to change these two cells. And these are the constraints that we created. and you just say solve, and solver will solve, and you can say okay, so you have the answer. So it says this is what you need to make, and maximum profit you can get is this. You can't get more than this profit. I hope I'm clear.
Yes, sir.
Okay, so this is how you solve maximization problem or minimization problem. We call it as linear optimization problem. Yes? Shall we stop here? Any question on this? Solve
No,
2-3
sir.
problems and you will master this. Okay?
Okay. Okay.